right. Well, hello, everybody, and welcome to the Graph Data and Code Show with first Denise Gosnell, Dr. Denise Gosnell. Hi, Denise.
Hey, David. Thank you so much. It's good to be
now
here.
I can hear you. Oh, it's wonderful. Now I can hear you. and myself, David Jones Gilardi. So for all of you watching right now, bear with us for a moment as we do this first of our Graph and Code Show live stream. So really, just to kind of break this down and what we're going to do. So Denise and Matthias, I'm still not going to attempt to say Matthias's last name.
Dr. Groschela.
Oh, there you go. Okay.
And I'm still not doing that one right. He's going to kill me.
So both Denise and Matthias have recently written an O'Reilly book, specifically on graph. And I'm not going to go too much into that because I'm not the expert there. That is Denise, and so I'll let her talk to that. But from a noob standpoint, right, from coming in, if you're first learning about graph, whether it's DataStax graph or graph databases in general, one of the hardest parts, right, can be that kind of starting off point. Like, it can get really intense really fast, and it can get really complicated. And even before, I like Denise, so I like to, say nice things about her and Matthias and that kind of deal. But even separate from that, when I had gotten a pre-version of the book and I was going through it, one of the things that really struck me was actually how well thought out the examples were and how good it would be for folks that are just starting into graph. We've, for a couple of years now with the DevRel team, we've been doing stuff where we've had our developer day events, we've done graph curriculum and such. And, it's one of those that can get really difficult really quick. And I actually really, really enjoy the way that the book kind of lays this stuff out. So Denise is going to school me. She is going to bring me through the book. And not only just through the book, we're not going to do reading time with Denise.
Okay. I should close it up over here.
No, you got your glasses ready. Were you ready for that? Right? But she's actually going to bring me through the book, and they not only created a book, but there is a whole GitHub repo with all sorts of exercises, real concrete use cases, everything. So we are going to every week we're going to step through this thing, and Denise is going to school me. Now I've said enough. I'm going to stop. Denise, tell us.
Yeah, no, this is gonna be fun. And just to kind of level set, we're watching a few places right here, so we want you guys to be asking as many questions as possible. I'm watching live on Twitter and I'm watching live on YouTube. Hello, I saw someone say hi on YouTube. So we're glad that you guys are joining us. So here's what we're gonna do. We want to get everyone's hands dirty into the code that we created for just trying to understand how to use graph technology and think about connected data. So as a part of that, we figured that we would have a good time with me kind of giving David just like a straight up tour on how to use all of the assets and just kind of start at the beginning. So for the next 40 minutes or so, our goal is we're going to try and first off, we're going to screen share with David. And we're going to show you how to get access to the Docker containers to pull the Docker containers down. I'm going to kind of give you guys a tour of everything that we have pre-baked and ready for you. And that's essentially going to almost be a tour from chapter 3 through 12 in the book. So you have an idea of all of the examples that we're going to be digging into over the coming weeks. And then depending on where we are, I thought we'd get started right at chapter 3, where we introduce the idea that a graph query is the reverse of SQL, where with SQL, it's all about select from where. And we get started in chapter 3 saying that graph is kind of the reverse of that. It's where from select, or kind of where join select. And that's where maybe we'll get started today. We'll see. We'll kind of see how far we get along. So that's kind of the plan. And I'll keep monitoring for questions across our various channels. But I'm excited to give you guys a front row tour into all of the code and everything that we wrote. So
awesome. All right. So with that, I guess, should I share my screen now?
Yeah.
We're just going to go for it.
Yeah.
All right,
so, I mean, basically anyone watching, you're kind of getting like a behind the scenes tour of how David and I have been working together to create content together, or to kind of create these examples. And we realized that if we're going to be diving so deeply into all this, let's just screen share and let everyone else follow along. So really, this is going to be pretty informal.
Yeah, and to that point about following along, that I'm pretty sure is totally doable. Like unlike maybe some of our workshops where we're throwing a lot of information at folks and kind of expect that there's going to be a little homework and that kind of deal. Denise is literally walking me through this in real time. So you'll get to see my like missed keystrokes and everything. This is going to be wonderful. Yeah, I'm so sorry if I share my screen and it's like, let's see what happens.
But that's what it's about. I think one of my favorite professors at the University of Tennessee, his name is Dr. Jim Plank, and he live codes all of his classes. And I've always
that's fun.
Yeah, I've always found that to be one of the easiest ways to learn and follow along. So that's kind of the theme here. We're going to have David be digging in, live coding, following everything, and we'll see how it goes.
Okay, cool. All right, so hopefully at this moment, I'm just double checking screens and stuff. You guys should see my screen. Now, for those of you who are following along, right, what I have done is I did cheat a little bit, not too much though, I swear, is, just so we don't have a scenario where you are watching me like download a bunch of Docker images and such like that. Hold on real quick. I'm getting some odd audio from somewhere. Please.
That might have been me. I was trying to follow along. Sorry.
Oh, is that you? I was like, which window is doing it? I thought that was me doing it to myself. So, that's great. So what I did is, again, instead of watching paint dry and watching me download a bunch of Docker resources and such, I have at least started up the containers and stuff once, right? So I've gone through that step, but that's it, right? Other than that, we're essentially going to be starting from scratch. And just break it down a little bit here. So the first thing I want you to notice is if you take a look at this URL that I'm looking at right now, github.com/datastax/graphbook, that is where all of the materials that we're going to be working through exist, right? So you can go to Graphbook, it's all open. And this is really cool. For those of you who are familiar at all with using DataStax Studio or whatever, when you're working with Apache Cassandra and DataStax Enterprise, you'll be very familiar with the notebooks and everything. For those of you who are not, you don't need to worry about it. The way that Denise and team have set this up, and we'll step through it in a moment, it's all enabled through Docker, right? Everything we're able to do or everything we're going to do, I can just do literally by cloning the repo and then saying Docker compose up, and that's it. It's that simple. The whole point is like get you up and running, right? So that's the first resource. The second thing, this is probably not needed, but it's something I, as a developer, I kind of do. If I'm doing things in Docker, I tend to have the dashboard up. That's what you see here. You can see I've loaded at least once, right? So if I need to look at logs or do anything, you'll see when that goes green. And then finally, I have a terminal. I'm using iTerm2. I have a terminal set up where I'm actually going to be issuing the commands, right? So it's really just the web page here, and then the terminals where I'm going to be working out of. Okay, so Denise, I was going to start just stepping through, but before I do that, was there anything that you wanted to have me do or kind of point out while we're here?
In. So what you've done is you went to GitHub, you cloned the repository, and you ran Docker Compose up?
No, I actually have Docker. I do not have it up, so I can do that now if you want me to.
Yeah, that would be great. So if you could go ahead and kind of spin up the container that contains all the examples, that would be awesome. That's where we want to start. Now, one thing I would like to point out for those of you who are familiar with using Docker and Docker Compose, you might see, oh, where's his -d? Well, in this particular case, I actually want all of the log information to come to the foreground, and I want to interact with it there just so you guys can see what's going on, right? Matter of fact, there we go. If I don't do that, then you're not going to see all this wonderful output. I don't know. Again, that's kind of something that's maybe a little geeky on my end. I like to see the output and kind of see what's going on. So I am just running it in the foreground, per the instructions. Actually, you'll see if you scroll down here a little bit, in the Docker quick start section, right? It'll say, okay, go ahead, go get the thing, and then run your Docker Compose up. This is literally what I'm doing right now. By the way, if you don't use the git command, you can always, in any GitHub repository, you can just say clone or download and say download zip, or you can just clone that there, say git clone that link. All right, so we're doing our Docker Compose up. We can see it's starting to run. We can see we have a bunch of output. And then the next part of this is, once this gets up, you're going to see they have this link. If you notice the link, when I highlight there, is actually going to localhost 9091, right? So it's going to go to my own. I'm going to go ahead and launch that.
And there we go. Okay, so I have a bunch of notebooks. Hopefully, Denise, you're seeing that.
Yep, perfect. I am, and I'm following along, looking for questions, both again on Twitter and on YouTube, if anyone has questions. So thank you guys so much for sending those in. I'll keep monitoring. That's why I'm looking in 18,000 directions right now. Okay, so this is to me, whenever we were writing this book over the past year and a half, like that 9091 where studio homepages, that's basically where I feel like I lived for the past year and a half. So right there. So right there, you're getting a quick glimpse into all of the assets that we have available. And the first thing you notice is that they're all appended according to the chapter. So we're going to eventually start with chapter 3. But let me just give you a quick tour of everything that's in here. So chapter 3, chapter 4, and chapter 5 are a package. They walk you through the idea of building a customer 360 application. It's basically where most people get started when they're wanting to explore the idea of using graph technology. So those notebooks all go together because they're telling us a sequential story. Okay. Chapter 6 and 7 are the next pair that go together. And then it's 8 and 9 and 10 and 12. So let me tell you just really briefly about all 4 of these use cases. Well, as I already mentioned, 3, 4, and 5 are the idea of moving from relational technology into using graph technology for a customer 360 application. The basic premise is you have data in different silos around your company, and you're trying to bring all of your strong IDs together to say, hey, this is my customer, and I want to know everything about them across all of my different data sources. And so that's the story that we'll walk through starting today, starting at chapter 3. A little bit further down the road, we'll get to chapter 6 and 7, which is where we will be introducing having time series data as a graph in Cassandra, which is just really awesome once you kind of get to see the really cool things you can do when you're modeling time series data in a graph and what you can do with that. So when we're getting to that application, the questions that we're trying to answer are, well, what happens if a cell phone tower fails? How do I figure out what components or what sensors on my network are no longer going to be able to connect to that tower because it failed? And it actually requires a dynamic distributed graph in order to answer that question. And that's what we're going to be getting into when we get to 6 and 7. For chapters 8 and 9, we moved to the third most popular use case for using graph technology, which is pathfinding. It's the idea, it's like the 6 degrees of Kevin Bacon problem, where everyone always wants to know, well, how am I connected to this person in my network? And so we're going to explore pathfinding in the notebooks for 8 and 9 in the context of exchanging Bitcoin on the Bitcoin OTC network. And there's some really cool ways that you have to flip the ratings of how much you trust somebody, because in order to do a shortest path problem, you can't just aggregate the trust scores as you go, because it turns into a longest path problem. So anyways, we'll get to all those details when we get there. And then at the very end, in chapters 10 and 12, we're going to be showing you how to build a real production recommendation system. And I say real in production because the idea of following users and movies to create that collaborative filtering example that a lot of the graph folks talk about, you need to have 2 systems. You need to have one that is doing the deeper analytics in a more, say, offline analytics cluster. And then you need to be pushing the shortcut edges or the actual recommendations to be querying them real time, like when you're looking at your app on Netflix and you want to say, oh, this is the recommended movie that you have or the recommended content. So that's what we're going to be getting to at the very end of this journey. And that's going to tie back into the number of partitions it requires in Cassandra to run those types of queries. So there's going to be a lot of content and a lot of coding. And that's the tour of the 4 stories that we're going to do. We're going to do customer 360, hierarchical data with time series, paths with Bitcoin data, and then we're going to do collaborative filtering with movie recommendations. Sound good, David?
One, for those use cases, right, the ones that you just spelled out that we're going to go through in all the notebooks, right? Okay. Now I'm going to play a little bit of straight man here, a little fourth wall. As I understand it, those use cases aren't just like arbitrary use cases that you guys like, let's do these, right? These are actually use cases and concrete examples from what you guys over so many years have experienced that people are trying to do with graph, like in the real world. Is that correct?
Yeah, David, that's really great. Absolutely. And when Matthias and I were thinking about how to organize this, we wanted to streamline into the templates of what types of graph projects made it into production. Because there are so many beautiful examples of really interesting ways to use connected data to solve a problem. But from our experience over the past 10 years of working with teams around the world, a lot of these problems maybe didn't end up with the business value that people wanted, or they just didn't end up getting sponsored. So they kind of fell through that crack of, oh, cool idea, but not going to end up in production. What we did is we took the common templates from what we have seen move into production, and that essentially became the 4 stories that we told in this book. The customer 360, hierarchical data, pathfinding, and then collaborative filtering.
I see. Cool. Okay. The next question, and you kind of touched on this as you were explaining and kind of giving me the rundown of the notebooks. I noticed this difference between some notebooks have dev and some have prod. I see dev and prod. I'm seeing this a lot. And I think what I heard you say was something along the lines of there are maybe ways that you would explore your graph or whatever in development that you wouldn't do in production. And there's going to be some different things you would do in production, say from an analytics standpoint or whatever. So
Absolutely.
I'm going to make an assumption. Let's see if I got this right. So I have a feeling that what we're going to see in the dev notebooks are exactly those. Like, how do I explore? How do, as a developer, especially when you're first figuring out your traversals, your queries, whatever, you might do things a little bit differently than you do into the optimized production. So is that where we're going to see you guys provided essentially examples on both ends?
Exactly. That's exactly it. So, if we focus in on like 3, 4, and 5, this is the only example that had 3. And the reason it had 3 was because chapter 3 was like kind of like the relational versus graph bake-off chapter. Chapter 3 really is just getting started with like the fundamentals of doing graph type queries, where we introduced the idea that gremlin really is just where join select, or the opposite of that select from, that select from where statement that is super popular. And that exact same dev prod pattern follows throughout every other use case in the book. So 3 and 4 are development, helping you think through your data, design queries, and think about how you're going to use your data and your graph technology to solve your question. And then in chapter 5, we lifted the final version of the query to essentially kind of talk about the production style of how you want to partition your data and the other types of guardrails that you might want to put on your query when you run it in prod. And we follow that same pattern, David, just like you said, for everything else. So like chapter 6 is development. Chapter 7 is production. Chapter 8 is development. Chapter 9 is production. Chapter 10 is development. I slipped in some entity resolution stuff in chapter 11, and then we go to chapter 12 is production.
Okay, awesome. And for those folks out there who, have been using graph for a little bit of time, right? And I'm giving a little bit of a preview on something. I'm cheating just a little bit because I have not gone through the vast majority of this material, but I've gone through just a little bit of it because I wanted to get a feel, right? Because the whole idea is that Denise is bringing me through this fresh. But one thing I did notice for the developers out there, and I got really excited when I saw it, especially for the times that I was doing stuff in graph development, is this usage of dev, this dev object that you can use that essentially kind of flips some switches to put you in like a development mode very easily just by using that object, as compared to having to switch a bunch of configuration parameters and such like that. I thought that was particularly neat. So I assume we're going to see a lot of those in the dev.
So why don't we go ahead and open up the chapter 3 notebook, and we can we can show them.
Now, one thing I think we should point out here is that since we're using the Docker image, and at any point, Denise, if I'm incorrect with what I'm saying, just shoot me down live everywhere.
I will nicely correct you.
No, you can shoot me down. Just do it. Okay, but what I want to point out is so since we're using the Docker image, another thing the Docker image does for you, actually, let me pop over real quick. Notice that the Docker image is not the only way that you can do this. If you want to, you could actually load down like the DSC 6.8 tarball and go about it like that, or you could do this in your own graph and such like that. Here's the difference, right? The Docker image comes with everything pre-baked. All the graphs are created, the data is loaded, and all that. It is uber fast. From the time when I ran Docker Compose up, I actually, I did this the other day, and I was like, I went to Denise later, and I was like, is all the data already in here? And she's like, yeah. I'm like, oh, because that makes it so you can literally spin this thing up in like 5 minutes and get going in the notebooks.
Yes.
Right.
Yeah.
If you don't have that, you have to do some other manual work, you know?
Yeah. Yeah. And so David, to your point, I'm looking at the GitHub repository. If you could scroll up to the top. Yeah, perfect. So then essentially right there, you have 2 directories inside the GitHub repository. So for some of you following along who are just going to take the Docker Compose route, I would go that route because everything's going to be loaded for you. And specifically what it's doing is it's going inside this data directory in the GitHub repository. And we wrote, so if you could click on that, we wrote some loading scripts. Perfect. Yeah. So we wrote loading scripts for all of the data associated by chapter. And I think if you click on chapter 10, that is the biggest one. Yeah. So chapter 10, you can see we've got a tarball of data. So we don't need to download that here, but you can see that on chapter 10, there's a loading script that is a way that it shows you how to load the data. And eventually in these live streams, David and I will get into loading data, but we won't do it on this first one. But I wanted to pull out chapter 10 as an example because we merged 2 data source sets together for the recommendations that are at the end of this, at the end of the book. We merged together Kaggle's movies. So I think they're pretty much the ground truth. They have the most movies out there, about 350,000, 326,000, if I'm remembering correctly. And then we merged that with the Movie Lens data, and the Movie Lens data has about 20 million ratings between some users of Movie Lens and movies. So we merged those 2 data sets together and provided all of that data in the tarball that you're showing here now. I see. Right. And so when you use the Docker setup, it's adding the schema into your graphs, which now if you're thinking along, you've got a graph for basically every chapter, a graph for chapter 3, a graph for chapter 4, a graph for chapter 5, all the way through chapter 12. And it makes those graphs, it sets up the schema, and then it loads the data for you so that when we're doing some of these live streams, we can get right to coding and thinking about how you want to write Gremlin to answer your questions. And I mean, we'll be sure to go into the loading and the schema at some point, but just not today.
Yeah, and like I just wanted to point that out because one of the first things that happens is when you come to the chapter 3 notebook. I know for myself, being somebody who has historically used Studio with Graph, and I did not create any schema yet when I used the Docker image. I came here and I was like, wait, it didn't prompt me to create it. And then I look, and as I was messing around, I was like, wait, there's a schema already here. I'm like, oh, this stuff is already in place. So it's just something I wanted to point out for those who may be familiar with this kind of stuff already. And you're taking a look, you're like, wait a minute, why am I not getting these things? It's because it's all there. It's all there when you use the Docker image.
Right. And on YouTube, I am putting a link to where you can get the chapter 3, chapter 4, and chapter 5 PDF for free. So if you did want to follow along, I just put that link on the YouTube comments for the people who are watching there. And I think that's actually turning out to be the easiest place for people to be sending in questions. So I've got Twitter and YouTube up, but send in questions through YouTube on @DataStax Devs if you're wondering where to follow so that you can ask us questions. But yeah, so David, to your point, here's the notebook. And we can start diving into some of the questions or some of the queries. So if you could maybe scroll down
let's do it.
To the, I have an image that's pulling in the graph schema. Perfect. You might just have to make that a little wider. Awesome.
You know, it's funny. There's there's maybe, I don't know, it's a couple second lag, but I'm hearing, I did it. And then I heard you after, so I felt like I had a moment of maybe trying to read your mind a little bit.
I love it.
Reading the mind of Denise Gosnell with you. Anyway.
David, by the end of this, I'm kind of scared on what you're going to be able to read. Okay. So David, here's what we're doing in chapter 3. So in chapter 3, well, I'm going to step back for 2 seconds. In chapter 1, we spent a lot of time talking about when to use graph technology and why it would be useful. In chapter 2, we introduce all of the vocabulary and we introduce something called the graph schema language, or the GSL. So all of the vocabulary and all of the notation that we're getting ready to walk through is outlined and explained, and we'll define it in context. But it all builds up so that this picture means something. because everything you're looking at here can be directly translated into schema statements, just like an ERD. So we probably want to go into a future episode where we really dive into all the details of the graph schema language and how we're using these images to essentially make the ERD for graphs, because that's also a part of what we're doing here. But once you get into chapter 3, it's like the common question, it's the debate that Matthias and I have to essentially moderate every time we try and help people get started with graph technology. And that debate is always, well, why not just use RDBMS for this? Relational systems would do just as well. So the example that we're walking through here, essentially in the text, we do the entire example in Postgres. And so what we're picking up here in the notebook is the exact same example, but starting with just using DataStax graph. So what you look at here, you're looking at graph schema. And in graph schema, there are 3 things. There's vertex labels, edge labels, and properties. And David, I think you kind of already know some of these bits, yeah?
Yeah, but let's pretend that I don't.
Okay, cool. So in this graph schema, you can see on the vertex labels, if you kind of read them, that we're talking about a banking example. So we have customers, and these customers own accounts, they use credit cards, and they also owe some loans in this fictitious bank that we're modeling.
Okay, right.
What we want to do in this notebook is to show how simple it is to combine graph databases with graph query languages to answer the question of tell me everything about this customer. And that's really what we're building up to in this example. Sound good?
Mm-hmm.
Cool. So let's scroll down.
Yep.
All right, let's scroll down. And like you said, the schema is already in the database. And you kind of get a glimpse at your first few schema statements there, where you can see that each of those vertex labels become part of the schema that we're making in this block. And pro tip for Studio, I think it's Control L turns on line numbers.
Oh, look at that. Well, it gave me a line.
It's either Control L or Command L is how you get your line numbers on the left.
Well, Control L did the first thing. Oh, that's there we go. I'm on a Mac, but for some reason I had to do that multiple times. I'm not sure what happened there.
Okay, gotcha.
Okay,
yeah.
Line numbers. Woo.
Dude, pro tip, I could not be navigating Studio without line numbers turned on.
That's a good point. So, yeah, it'll help us kind of pinpoint exactly what we're talking about.
Yep. So when you're starting with your graph schema, just like in any other database, you have to say what piece of data uniquely identifies this vertex, where a vertex just represents like a single entity. And as you can see on line 4, where we define the partition key?
Yeah.
Yeah. So the partition key for this customer is going to be an ID. So just some customer ID. And that's all that is meaning. That just says that this customer ID is going to represent this unique entity or this unique vertex in my graph database.
And something to just kind of state here, right, is that this graph database that we are working with for DataStax Graph is built on top of Apache Cassandra.
It is.
Right? So this partition, for those who are familiar with Apache Cassandra, right, and again, correct me if I'm wrong, but this partition is going to be the same kind of, it's a partition, right? So this is our partition key, essentially, customer ID, is that correct? Correct.
That is correct. And a question that just came in from YouTube. Hey, Ankit, it's good to see you. Another question just came in. Do we need DSE to use Cassandra Graph? Can we use Graph on top of Cassandra without DSE? The answer for that question, all the examples that you're going through here do require DataStax Enterprise and using Graph on top of DataStax Enterprise. That all is available in this Docker container setup, though, so you have the ability to play with this on your desktop.
Right.
On
you don't need a license or anything like that. You can just download it.
Yeah.
Okay.
So, good question. Thanks for that comment. Thanks for bringing that in. So this just set up our schema, our vertex labels, and I mean, you can still execute the schema statements. It's not going to mess anything up in the database. Yeah. So
those wonderful if not exists, right? They kind of
exactly
help us with that part. And you can see it being executed over here and saying, here's the actual underlying CQL statement. That's kind of fun.
Yep. Cool. So that's why
I like that stuff.
Yep. Yeah. So we just made 4 vertex labels in the graph, one for customer, one for their accounts, their loans, and then their credit cards. And we gave them all unique keys.
And these vertex labels then correspond to what we were looking at here, loan, customer account, and credit card. So we're creating these vertices, correct?
Correct.
Okay.
Absolutely.
Okay.
So the other three things we need to make now are those edges. So let's go make the edges.
Right, the edges, the O's, owns, role, and uses. Okay, so scroll down.
So there you go. Whenever you're making edges, you just want to say that you're connecting. This edge label connects from this, and then you provide the vertex label, and then to, and you provide the vertex label it's connecting. So we're going from customers to loans, and that's the first edge that you're making.
And that's like really simple. So those are literally the vertex labels we just created. So that's it. We're just connecting one from another. We're essentially taking this schema, this visual representation of the graph. We're saying, I want to connect from this to this with that edge.
Yes.
And the first one there was, O's, customer to loan. Okay.
Yep. Absolutely. So the only real difference here is on that last edge label, the O's edge label. You can see that we have a property on that one.
Okay.
Yep. That's the only difference between the two. And
I see.
Right. So we go into detail when we're writing about this in the book, but the idea is that a customer can own an account, right? And you might have multiple roles. So you could be the creator of that account, or you could be an authorized user. You could be the owner. Like there's many different ways that you could actually control that account. And this is also a very, very like deep modeling discussion that you can get into. But you see how that line from customer to account is a double line?
I was going to ask you about that because all these others look kind of similar. And when I looked at the edge statements, they didn't have properties, but this one had the property and had the double line. So yeah, that's exactly why I scrolled back up here, by the way. I was going to ask you.
Yeah, no worries. And there isn't standard notation to describe this. So we kind of invented this notation. We'll see if it takes off. But here's the idea. In Cassandra,
double arrow, what does it mean? Sorry, I had to do it.
It's okay.
I had to do it. Sorry. I should say double line. Sorry. Anyway.
No worries. So the idea here is that between, like, David, if you're in the database and we have the David vertex and we have the account vertex, the double line means that you want there to be multiple edges between David and the account. So David is the owner, David is the authorized user, and David is something else, the creator of anything, right?
Okay, so David essentially has multiple roles here.
Correct.
And we are representing that with multiple edges from the customer to account.
Yes. Okay. Because when you're doing graph data modeling at the schema level, and for people who are following, this is probably the most important thing to know about data modeling with graphs. Everything starts at many to many. The idea of something being one to many or one to one in graph databases does not make sense. So what we're doing here is we're giving you a way to take a many relationship, but then provide multiple edges between two individual vertices. And that's what we're doing down there in those schema statements when you have a cluster by role. Because now, if you add an edge, you have the ability to have many edges from David to his account. So that's what's happening on that line right there.
Okay.
Cool.
Okay. Cool. All right. Neato. All right. I think, we're here. All right. So we've got our schema, right? We've got our vertexes. We have our edges. And I'm going to assume by this next section, we're going to put stuff in it. Yep.
Okay. So inserting some data. And that's what's happening here. So David, do you want to give a go at what's going on with this gremlin statement?
Well, let's see. So the first thing is I do see a reference to G. It looks like we're adding a vertex. So we set up our schema, right? So we set that up, and now we're going to put some data in there.
Absolutely.
So we're going to add a customer vertex. It's going to have a property here. I see we're giving it an ID of customer 0. It's going to have a name of Michael. So I'm making a base assumption that after we do this, if we were to then, look at our graph, we would actually see now that we have a customer vertex with those two properties. Well, I don't know if we'd actually show the ID or not, but we'd at least have the customer vertex with a property name and Michael.
Absolutely. And that's all accurate. And that next statement, that terminal statement at the end called next, that's a way to execute this gremlin statement and then store the resulting object into the variable named Michael.
I did miss that. Yes.
Yeah,
Sorry,
so
I
actually,
forgot
if
that.
you click on Studio's graph visualization feature, you can see it in the database. Do you see that?
Far right.
Yeah, that one. There you go. There's
There
your
we go.
customer.
Yeah.
And then if you
Okay.
click
And I
on
guess, oh, go ahead.
if you could click on the settings wheel, not the settings wheel for the visualization. That one.
You want
Yep.
to change? Yeah.
Yep.
You want to change some labels?
Yep. You can change it. You can just put name.
I guess I could have done that as a global default.
No worries. I just wanted to show people how to do that.
Yeah, if you don't want these like very verbose and terse names, right? Notice now, as Denise had instructed me, we use the mustard language, I believe, and you can specify what the actual property name is there, and now it's much prettier now, right? It's
Yeah,
not
a little bit easier to see.
It's some weird reference. Yeah,
Cool.
exactly.
Okay, sweet. So we have built our schema. We have inserted a vertex. Let's go add some more, because I think in this book we had 5 people that we were inserting. So let's scroll down and insert some more, which I think we move on to. Yes. So this one right here.
Oh, look at this.
Pop quiz. Why did that fail?
It looks like there's no reference to the ID.
Exactly. So this is Cassandra under the hood. So if you don't provide the full key, you can't insert data.
Oh, okay. So let's further this on a little bit, because we talk about this a lot in our Cassandra development workshops, right? That one thing is absolutely required in Cassandra, and that's that partition key, right? So what I think I just saw here is that by not providing that partition ID or that partition key in this case, this would be similar to what would happen is if I tried to insert something like this directly into a Cassandra table and I didn't provide a partition key. It's going to yell at me.
Yes.
Right. And that's what I believe I'm seeing here.
Yep. That's it.
Okay. Now, do we want to fix this, or did you guys just put this in here as an example as, hey,
I just put it as an example. This entire series is learning through failing. So there's a ton of there's a ton of times where I like,
if you want to fail a lot, watch our series.
Well, I mean, I don't know. It's whenever I started getting used to working with Gremlin and graph technology, I felt like almost for every one query I figured out, I had probably 10 massive failures right before it. So that is the development experience. And I kind of come from the camp of if you're not breaking things, you're not coding hard enough. So
there you go. No, and I actually think this test is a really good example. It illustrates again the fact that this is Cassandra, right? This is Cassandra under the hood.
Yes.
So if you keep that in mind and you kind of understand some of the reasoning behind things or some of the constraints, things like, again, partition keys and why you need those, then it starts to make sense why you might get this error and why that happens. And then it's that much easier as you're going on to not make that mistake again. So I think that's a good example.
Cool. So for those of you who are still following along or maybe have jumped in, the big thing that we're trying to get to today is doing a graph query that shows you how graph languages are the reverse of SQL, where SQL is like select from where, and we're eventually building up to show you that graph queries are the reverse, where from select, or I like to call it where join select. So that's kind of where we're navigating to. And David has inserted one vertex into the database so far, and we're going to go down and we're going to add some more vertices and add some edges.
Okay. All right. So you want me to do these?
Yep. Okay. So what do we add in here?
Well, it looks like to me now we're starting to fill it out a little bit, right? And by the way, I'm just going to pull up our schema. It's a little easier for me because I have squirrel memory syndrome. And here we go. Hopefully you guys can see that well enough, right? So we were just a moment ago, we were doing things, we were setting up, inserting some data from the customer to account, right? But it looks like now we're starting to fill some things out a little bit. Adding another account in here with an ID of account 14, then adding a loan vertex, loan 32, and then adding credit cards. So we're starting to fill this out a little bit more.
Yeah, so we only have 4 vertices in the graph. We have Michael and then the 3 things about him. So in the next cell, let's go ahead and add the edges so that we connect them together.
Okay, right. I see. So we've added these vertices. Now we want to add edges, which makes sense, right? You can't, I would assume that you have to have some vertices before you can add edges to those vertices.
You can't say like add an edge from this customer to a loan when there's nothing over there. So. Okay.
So in this case, because I feel like you're going to ask me, it looks like we're adding an owns edge, owns from Michael to account 14. So from the customer to account. And then we're giving it, using that that one property, the role property we talked about as primary.
Yep.
And then we have owes. So that's going to be from Michael to loan 32. So Michael then owes on a particular loan. And then for uses, we're going to add a uses edge, again, from Michael to our CCR credit card. So Michael uses some credit card, he owns on some loan, and he owns an account. It has the primary role. That's what I'm getting out of that.
Yep, that's it. That's it.
Okay. And I assume that if we look at our visualization here, we'll start to open this up a little bit. Here we go. Right. Actually, while we're here, let's go to our global defaults. I'm assuming is credit card. What's its, I didn't see what the name of the property was. It name again?
I think it's CC_num. Like num as a number.
Oh, there it goes. Yep. Yay. Cool. All right. To make that nicer. So we can see here. Now this, if I'm right though, we're not, at this point, we're not really traversing the graph and trying to explore it. We're just getting the output from when we added this. So I believe we're only going to see the very last one that's in this case.
Correct.
Compared to if I were to actually queried my graph, right? But you do start to see now, I've got Michael, I've got that vertice. Again, you can see when I hover over it on the left-hand side that it's a customer vertex that uses with the uses edge over to this particular credit card.
Okay.
That we created before. Okay.
Do you think you could make, I'm getting a question here on Twitter, not on Twitter, on YouTube. Can you make your screen a little bit larger? Some people are saying that they're having a hard time.
Yeah, let's try it. Here, let me see how crazy I can go with this. Are people having a hard time reading the text? Is that what's going on?
Yes. Yeah. We got a comment here that it's not as clear. So maybe if we make it a little larger, that would help.
How's that? I blew it up a little bit.
Well, I just responded on YouTube. I will see if that makes it better. If they respond. Thanks for the feedback, guys.
Yes, thank you for letting us know, and I'll zoom in a little bit here so you guys can see the scheme a little better. Okay, cool. Hopefully that works better. I can do the same over here while we're here.
Awesome. All right. Well, let's keep on going because I think we've got about 10 minutes left in this live stream, and we are so close to getting to our first graph query. So at this point, we've added Michael and his information. And because we're using the Docker setup, we don't have to go through and add all the rest of the ones because they're already in there. But what is happening is that in the book, we're telling a bigger story. We have 5 characters. So this is Maria. Everyone meet Maria. We're adding Maria into the database. And if you want to keep on, you can execute them if you'd like. But because you're using the Docker setup, it's already loaded. Right. So who do we have
see.
here?
So really, this is us. This is, rinse and repeat, right? We're essentially just adding more data, more varied data, going through the same mechanisms that the same syntax and everything, other than it's different data is what it is.
Exactly. So we have another character named Rashika. We added Rashika's data. We have Jamie.
Okay.
Jamie's data. And lastly, if I remember, Aaliyah. Yep, Aaliyah's data.
Aaliyah, yeah. Okay.
Awesome. So we have 5 people now. We have 5 people in the database. And there it is. There's everybody. So if you want to, I think, is that a hidden gremlin query?
Oh, yes, this looks like it. Yep. Oh, I see something already. That's fun. I don't know if we're going to talk about it today, but I see you're using dev.
Yes. Yeah. So for anyone following along who has been a user of graph data before, David just picked it out. We have a feature in our next product over here called dev. And dev is a new graph traversal source. That just means that when you start a graph traversal with dev dot, it's going to basically let you walk through your graph index free. And we deployed that so that, and shout out, thank you so much to Bryn Cook who did that for us just for this book.
Oh, nice, Bryn.
Honestly. But we did that because so many people were, you want to make sure you have a place to explore your data, but then you also want to have a hardened traversal source that only allows you to do production quality traversals. So we split that up and we teach all of the development chapters in the graph book just using the dev traversal source, which you can see here pulls out every vertex and every edge in the graph so that you can get a visualization of the data we have, which there's our 5 people. And it looks like we have some shared accounts and credit cards for some of the people in our story because you see 3 connected components. The green vertices are one connected component. The orange vertices are the next connected component. And then the blue vertices are the third connected component.
So something I'm noticing here, again, making the connection with Cassandra, And again, asking you to correct me if I'm wrong, but it looks like here we're literally pulling all of the vertices and then stepping out along all edges, really, both E, right?
Correct.
So this is like I just did a select star.
Yes.
I'm doing a full scan right here, right?
Full scan, select star across every table in the entire database. So I would never do that in production.
You would never do that in production. Exactly. That's exactly what I was driving at. Is that this is the same thing that we talk about, right, in the workshops when we say, yes, you on a small data set, if you're doing a quick test, can you do a select star, just get an idea what's there? Fine. But you never really want to use that, especially as you start to scale up your data, because we've only got like, a dozen data points here, maybe, or something like that. But imagine if you had 1 billion, right? Imagine if you had 1,000 node cluster that you had on this and you did this, right? So that's also something, help me understand with dev. I'm making a guess at what I think some of dev is doing, right? Because I know that in previous examples of graph, you would have to explicitly configure certain parameters to enable to get the functionality that you're getting with dev right now. And it looks like dev is just doing that for you.
It is.
It's maybe where you're taking.
Yeah, it's making it easy to walk around your entire graph with no indexes, essentially.
Okay, yeah, where before you'd have to specifically tell it to allow to do that, allow scanning, allow all sorts of things. So it's letting you do it.
Yep.
So it sounds like great dev, but dev has no protections, right? If we had a billion rows in this thing and we actually just tried to do this, we would just scan them all regardless.
Correct. And behind the scenes, you won't be able to use dev in a full cluster. So there's a few other guardrails we have in that traversal source.
Oh, good. Yeah. Okay, we'll get there then. Okay,
we'll get there. Cool. So let's keep going.
Got it. Right.
And let's get to our first query. So the way that I like to think about graph queries is that we're going to basically do this one example, and this will kind of be the end of today's live stream since we've done so much.
Okay.
But understanding graph queries, graph data, graph technology, it's all about being able to answer higher level business questions. So this entire notebook and every question in this book is doing query-driven design. The very first question that we're setting up is, can you tell me which credit cards this customer uses? And it looks like we're using Michael, customer 0, as this first example. So you have to kind of think back to our schema and imagine, just like you would if you were in a new city and using Google Maps, you kind of have to imagine how you're going to use these edges to walk around your data. And that's what we're doing here. We're starting at the customer. We're walking over the edge called uses. And once you walk over that edge called uses, you're standing on a credit card. And so you want to get that credit card number. And this exact process is beautifully the reverse of select from where. And that's why you see all those comments. Anything that's a double slash and then it's grayed out, that's how you do comments in the Gremlin or the Groovy programming languages. So I provided lots of comments that you guys can see the mindset that we're trying to teach on how to use this query language. So that first line is essentially where you're starting your traversal. I want to start on customer 0. The second line, you go down to out uses and you're saying, I need to join everything to you. I want to follow this join through the uses edge. And now once you walk over that edge, you're standing on credit cards and you want to select their credit card number. And so that is exactly how I see graph traversals. They're the reverse of select from where. It's where join select.
Yeah, and I see now in your comments where you get the where join select. There you go. It's like, I was like, oh, okay, that makes sense. Okay.
Yeah, so I think you probably could run that one. That one should be ready to go, right?
Yeah, I believe so. Yep. Okay, so I mean, and just to kind of reiterate, so, looking at the schema, right? So we start with a customer. Obviously, we identified customer 0. Then she said, we're going to go out uses. And I see that our edges, we didn't really talk about this yet, but the edges have directionality. And, so they go from customer to credit card. So I'm going to go out uses. That brings me to a credit card. Where you said, if I imagine I have like a little gremlin, I'm standing on the credit card now, and I'm getting the value of whatever the property there is. In this case, that's CC num.
Yep. And it might be the next one, but I think most people who want to do these queries, they want to essentially do a select star. Oh, okay. We do accounts. So we're walking specific edges. So let's keep scrolling because I'm looking for the query that's like, get me everything. Because that's one where it gets really fun. Okay, we might want to start there next time. I forgot about this.
This little section.
Yeah, I forgot about this section. So, we only have a few minutes left. So we'll just kind of mark this as where to start next time. But essentially, that question of start on customer 0, go out, and we're providing the parameters of which edge, you can essentially leave that blank and it'll go out all edges. And that's the way to essentially do select star about everything connected. But we'll start there next Tuesday. So.
Okay, awesome. All right, so with that, let me see if I cannot, I realized this thing has a little widget to hide. Here we go, stop sharing. I lost the widget had a little widget on the bottom of the screen share, and I lost it. I'm like, I don't know how to get back out of it. But apparently it was easy.
Yeah. So we still have a few people following on the live streams. Thanks so much for staying all the way through this. So we did a lot. For those of you who maybe joined halfway through, David showed you where to go to get started, which is going to be github.com/datastax/graph-book. We use the Docker Compose setup to pull up the containers so that all of the data and schema is ready to go. Yep, that's it right there. And when we had that up, we took a tour of the whole book, which this book tours the 4 most popular patterns of people who are using graph technology in production applications. Those patterns are Customer 360, hierarchical data, paths, and then collaborative filtering. So throughout these tutorials, these live streams, we're eventually going to get through all of that. And today we started with the very beginning, which is doing Customer 360. And we kind of just took a quick tour through one of those notebooks to doing our first Gremlin query, where we like to think about Gremlin queries as the reverse of SQL, where SQL is select from where. And we kind of did a Gremlin query, which was where, join, select. So that is everything that we did during this first hour live stream. So what do you think, David? How'd that go?
I think that's a good place, and we'll give folks a moment to digest things. One thing I do want to point out for those of you, and we're going to do this later on in the series, but for those of you who really like to kind of get your hands dirty or something like that, it is worth, even though the Docker image is set up to provide everything for you, I think it's worth to actually step through how to load the data and use the bulk loader and do that. I think it's very informative. Again, we're going to do it later on in the series, but if you like to get your hands dirty, the instructions are all there, and we'll do more. But anyway, no, thank you guys, and thank you, Denise, for starting this up and like getting through this first iteration. We are going to continue to go through the whole thing. Yeah. Every week, we're going to do it. We're going to do it with you. Please bring yourself, bring your friends, bring your questions most off, because like you get this kind of time to pick Denise's brain, and it's unique Denise time. So it's always worth it. Anyway, with that, everyone, thank you guys for viewing, and we'll see you again next week.
Thank you so much, David.
Talk to you.